Hi students, today we are starting a new topic, that is miscellaneous treatment of water. In this I will discuss about aeration and adsorption. Miscellaneous treatments are aeration, removal of iron and manganese, removal of color, odor and taste, etc. The purpose of aeration is to make water fresh by absorbing oxygen from air and also dissolve gases to atmosphere, to remove both taste and odor, to reduce corrosiveness of water, precipitate iron and manganese to some extent by oxidizing, to kill harmful bacteria to some extent, to mixing chemicals to water. How does aeration work? Aeration is the intimate exposure of water and air. It is a way of thoroughly mixing the air and water so that various reactions can occur between the components of the air and the components of the water. There are two methods, that is scrubbing action and oxidation. These are the two methods, scrubbing action and oxidation. Scrubbing action is caused by turbulence which results when the water and air mix together. It is scrubbing action. When we mix this water and air together, there is a scrubbing action occurred in water. The scrubbing action physically removes gases from solution in the water, allowing them to escape into the surrounding. This also removes taste and odor from water. Next one is oxidation. Oxidation is other process through which aeration purifies water. When air is mixed with water, some impurities in water such as iron and manganese become oxidized. That becomes iron oxide and magnesium oxide. Once oxidized, these chemicals out of the solution and become suspended in the water. The suspended material can be removed later in the treatment process through filtration or sedimentation, etc. Efficiency of aeration process. It depends almost entirely on the amount of surface contact between the air and water. The contact is controlled preliminary by the size of water droplet or air bubbles. The goal of an aerator is to increase the surface area of water coming in contact with air so that more air can react with water. How we can remove iron and manganese from water? Mainly iron and manganese are present in well waters that occurs as soluble ferrous and manganese bicarbonates. In aeration process, the water is saturated with oxygen to promote the following reaction. That is, ferrous bicarbonate reacts with oxygen in water that forms ferric hydroxide and carbon dioxide. In case of manganese bicarbonate reacts with oxygen, forms manganese dioxide, okay, and carbon dioxide expels. What happens, the oxidation process or product of ferric hydroxide and manganese dioxide, these are insoluble. After aeration, they are removed by clarification or. These are the type of aerators. The type of aerators. Free fall or gravity aerator, that is divided into four types: cascade aerator, inclined apron aerator, salt tray aerator, gravel bed aerator. Then another spray aerators, air diffusers, mechanical aerators, etc. The free fall or gravity aerator. First one, cascade aerator. That is simply a free fall aerator. We can construct in concrete or metal. 1 in 3. In this aerator, we can reduce 50 to 60% of current. This is the cascade aerator. We can see that this is one tray. This is the inlet rough. There is a cascade, means here a step is constructed. The water is coming through this. Then we collect it in the outlet tank. This is cascade. This is the inlet portion. Water coming through these steps, and we are collecting it in this tank. These all are cascade. That is only a gravity. These all are cascade type. There is a step portion. Next one, gravity type, inclined apron aerator with riffled plates. That is, water falls in inclined plane or aprons. The water is break up due to the apron present in it. Okay. It is riffled plates. Breaking up of water due to aprons. We are constructing aprons in between the inlet and outlet. The agitation increases contact of air and water. Ruffle balls means small break. Its figure is not available. Next one is slat tray aerator. That is closely stacked superimposed wood slat trays. Wood slat trays. This is the figure of a flat tray aerator. Water is sprayed evenly on the top of the tray. You can see the inlet portion. Water is trickles from one tray to another. The distributor is also shown in figure. Tray is also shown. The water trickles from one tray to the other. Air is supplied from the bottom with the help of blowers. Airflow in upward direction. Ventilator is provided in the top, which discharges the air, and that is carbon dioxide or other gases formed in the process. Okay. This is the slat tray aerator. Next one is gravel bed aerator. Gravel bed aerator, there are two types, gravel bed and trickling bed. Gravel bed aerator means water is sprayed at the top. It trickles down the bed of gravels. Here it gives us bed of coke or anthracite. It is mainly gravel bed aerator. The gravel bed aerator, you can see the water is trickles that is sprayed from the top and trickles down to the gravel bed, and a blower is connected, air is rising upwards, and the aerated water is collected in a tank. And next, gravel bed aerator, there is a trickling bed aerator also, filled with cocoa stone. Thickness of bed is like this. The trickling bed aerator, that is coke is filled, cocoa stone is filled in for beds, and water is distributed from the top and air is supplied from bottom, and same manner that is gravel bed aerator. Next one is spray aerator. The name itself gives what is spray aerator. That is, water is distributed in air in the form of small droplets by means of orifices or nozzles. That is, we are pressurized the water in air. It requires a large area to collect the water. That is its disadvantages. We need a large area. Next one, diffused air aeration system. That is, the liquid is aerated in the form of bubble, and the bubbles arises through the liquid. That is mainly oxygen, or that is oxygen is applied to the water and it forms a bubble. That size of bubbles varies from coarse to fine bubbles. Then it diffuses. That is diffused air aeration system. Next one, mechanical aerators. That is, we using two type of shafts, vertical shaft and horizontal shaft. The shaft rotates and oxygen from atmosphere and the water. Next one is adsorption. Adsorption process. That is, adsorption means dissolved substance, that is adsorbates. Adsorbates and adsorbent. Adsorbates means dissolved substance and adsorbent, that a solid material that adsorbs. Here shows an example. Color can be removed from water using activated carbon. Color is the adsorbent. Adsorbate means dissolved substance. Adsorbent means which we use as an solid material for absorbing this substance. That is, activated carbon is the adsorbent. The adsorbents mainly activated carbon, then activated alumina, molecular-cis, that is zeolite. Zeolite is what is zeolite? Zeolite is hydrated aluminosilicate minerals. Okay. Or otherwise it is called as green sand. Organic compounds, removal of inorganic compounds such as nitrogen, sulfides and heavy metals. Chemical reduction of oxidants, removal of taste and odor compounds. Next one is a fluidized bed. That is, the bed is not fixed, it is fluidized, it is a moving bed. The impurities will remove from the bed, and liquid purified liquid can be out from this bed. But this process is not effective as filter. Another fixed bed system, that is a breakthrough development, is shown in this figure. This area is saturated zone, this area is adsorption zone, and this is the clean zone. Okay. That is, the time to breakthrough is decreased by increased particle size of carbon, higher concentration in the influent, increased pH of the water, and increased flow rate, lower bed depth. That is, this point is breakthrough point. This is the exhaustion area.